From a tornado with 200 miles per hour winds that no one could see to one that has only 2% chance of happening, these are some of the most unique tornadoes in the history of the USA that scientists still can't explain.
They hit that! It destroyed that window! They hit that window! Shredded that window!
This is one of the most iconic photos in tornado history: dead man walking. A tornado split into two, which almost looks like destruction is walking your way. This has happened more than once, and interestingly enough, scientists still debate what it exactly is. One tornado is a deadly enough devil. Imagine having to deal with two, or how about three? Yep, that's tornado splitting for you, a rare phenomenon when one vortex divides into two, or sometimes even more vortexes that coexist at the same time. Those aren't two separate storms moving apart. They are massive suction vortices revolving around a common invisible center. It's a huge debate in meteorology. Did the tornado actually split like a cell, or is it just one giant blender with two very large blades? Usually when a supercell cycles, the old tornado dies before a new one forms. But on May 24th, 2016, near Dodge City, Kansas, the storm did something that stunned storm chasers. It didn't just cycle, it split. Here, instead of legs, we see a full-blown family. Not one, not two, but multiple funnels. Each one is capable of deadly destruction, and even more. Tornado splitting is a massive scientific headache because it defies the basic survival of the fittest rule of physics. Typically, nature allows only one dominant funnel to exist. The strongest vortex should steal all the available energy, quickly choking off any competitors. For two powerful tornadoes to coexist without killing each other, the storm must maintain a perfectly balanced, chaotic state that contradicts standard fluid dynamics. Scientists still struggle to explain exactly how nature sustains this impossible equilibrium instead of letting the strongest tornado win. Tornadoes can be spotted from miles away. After all, they are 200 miles per hour winds, right? These giants touch the ground from the sky, quite literally. But what would you do if you can't see it? Tornado close call. Rain-wrapped beast. Low contract funnels are fully formed. Violent tornadoes that are virtually invisible because they lack the contrast needed for your eyes to pick them out. This deadly camouflage typically kicks in for two reasons. Either the tornado is rain-wrapped, completely hidden behind a thick curtain of falling water that matches the gray color of the funnel, or the lighting is simply terrible, where a dark background sky or blinding backlighting erases the tornado's silhouette completely. Instead of a clear warning, all you see is a dark, murky wall of clouds. It's an ambush where the predator hides in plain sight, and by the time you realize that fog is actually rotating, you're already in the danger zone. While we're grateful for the modern technology that we get warnings well before a tornado, things were not so great back in the day. And a low-contrast funnel then was nothing short of a silent death. On April 10th, 1979, in Wichita Falls, Texas, a low-contrast tornado took the lives of 45 people and destroyed over 2,500 homes. It was an F4, and to think that you couldn't even see 250 miles an hour winds until it picked up rubble is a deadly thought in itself. The rotation is violent, the pressure drop is extreme, but for reasons scientists are still analyzing, the moisture doesn't condense. You don't see the tornado, you only see what it destroys. Physics works towards predictability. We see patterns. We try to predict those patterns, and they become the rules. One of those rules is a well-known fact that all fans of tornadoes know. In the northern hemisphere, tornadoes spin counterclockwise, and in the southern hemisphere, they spin clockwise. It's physics 101, right? But sometimes nature doesn't adhere to them. Well, meet the rebel of the family, the anti-cyclonic tornado, the rare outlaw of the family. These rare freaks of nature, making up less than 2% of all tornadoes, spin clockwise in the northern hemisphere. It's like watching a clock run backwards, or a car speeding down the wrong side of the highway. It is just wrong. Usually, these are smaller satellite tornadoes that form on the trailing edge of a massive supercell, spinning in the opposite direction of their big brother. But in rare cases, like the famous Simla, Colorado event, they can become fully formed, independent monsters. Seeing one is a bucket list moment for storm chasers because it proves that even with rigid atmospheric laws, nature still loves to break them. In rare cases, like the 1970 Lubbock, Texas event, we see another example of the anticyclonic tornadoes. These storms spin clockwise, fighting the natural rotation of the parent supercell. While usually weaker, they challenge our understanding of supercell anatomy. In Lubbock, while the main funnel spun normally, a satellite vortex spun the wrong way, carving a path of destruction that baffled researchers for decades. There's an old survival myth that says, if you want to escape a tornado, head for the hills. The logic seems sound. How could a tornado possibly climb a mountain? Mountains are supposed to be tornado killers. The rough terrain disrupts wind flow, and the high altitude usually lacks the dense, warm air needed for combustion. But if you follow our channel, you know tornadoes can happen anywhere, even on high mountains. That's why August 11th, 1999 was never expected. A tornado touched down in Salt Lake City, Utah, at an elevation of over 4,200 feet. It wasn't a weak dust devil, either. It was a big one that tracked directly through the metropolitan area. It defied the terrain shielding theory, proving that if the atmospheric instability is violent enough, altitude offers no protection. And it's happened more than once. Rockwell Pass in Sequoia National Park is probably the most iconic. On July 7th, 2004, they witnessed a tornado touching down at an insane 12,000 feet above sea level, the highest tornado ever recorded in the US. See, tornadoes don't actually care about altitude, they only care about ingredients. They need warm, moist air and wind shear. While those ingredients are definitely harder to find at the top of a frozen peak than in a Kansas cornfield, they aren't impossible. When the atmosphere gets the recipe right, a tornado can form on a plateau, a ridge, or even a summit. So much for the safety of the high ground. Finally, we have the most chaotic phenomenon known to man, satellite tornado swarms. If a tornado splitting wasn't enough, imagine a massive parent tornado that gets so powerful it captures a second, independent tornado in its orbit, just like a moon circling a planet, hence the name. This isn't just a multiple vortex tornado. This is a large primary tornado that spawns entirely separate, independent tornadoes that orbit it like moons around a planet. And they are some of the most unexpected tornadoes as well. This isn't a split. These are two separate storms locked in a deadly dance. The central parent tornado moves slowly, while the smaller satellite tornado races around it at breakneck speeds like a sidekick. This is a nightmare for storm chasers. You might be watching the main beast, thinking you're safe at a distance, not realizing a silent, super-fast satellite is flanking you from the side. These satellites are often extremely violent and unpredictable, sometimes spinning even faster than the main tornado itself, before they eventually get swallowed up by the parent circulation. May 31st, 2010, near Campo, Colorado, a massive cone-shaped tornado is already churning up the open plains, a monster in its own right. But suddenly, a second thinner rope tornado drops from the sky right next to it. Instead of moving away, it gets locked into a deadly orbit. This is the textbook definition of a satellite tornado. In the footage, you can clearly see the main parent tornado moving slowly, acting like a planet with its own gravity. Meanwhile, the smaller satellite screams around it at breakneck speed, completing a full lap around the giant. It's not a split, and it's not a twin. It's a parasite feeding off the parent's energy. It spins violently around its host before eventually being swallowed whole by the main circulation. It remains the clearest evidence we have of this terrifying atmospheric dance. On April 27, 2011, during the historic super outbreak, a massive tornado was tearing through Cullman, Alabama. But it didn't come alone. In the famous footage, you can see the giant parent storm looming in the background, a dark, lumbering wall of destruction. But that's the least of your worries. A second razor-sharp drill bit tornado starts brewing, and to make matters worse, it was moving significantly faster than the one behind it. This satellite wasn't just a weak sidekick, it was a violent monster spinning at insane speeds, flanking the main storm. It highlights the true danger of these systems. While everyone focuses on the giant tornado, a hyper-fast satellite can slash through a neighborhood independently, catching people completely off guard before they even see the main event. Modeling, this is a nightmare for scientists. The interaction between the parent and the satellite creates erratic, unpredictable paths. The satellite can accelerate to extreme speeds as it gets slingshotted around the main funnel, making it nearly impossible to escape if you are in its path. From the invisible to the impossible, these storms remind us that the atmosphere is a chaotic fluid that refuses to be fully tamed by math or science. Which of these weather anomalies do you find the most terrifying? Or is there a specific storm you want us to break down next? Let us know in the comments below.